Good morning, everyone. Today we are going to learn one of the most important topic in machine learning, that is neural networks. Before we start, I want you to understand why neural networks are needed. Yeah. So in traditional programming, we write rules manually. For example, if marks are greater than 35, then they pass. If marks are less than 35, then fails. So in but now think about problems like face recognition or speech recognition or handwriting recognition. Can we write rules for the programs? No. So exactly, we cannot write rules. So instead of giving rules, we give data and the computer learns the rules by itself. So that learning model is called a neural network. What is neural network? Now we are going starting with what is neural network. So a neural network is inspired by human brain. Our brain is made of neurons. Each neuron receives signal, process them, and sends them output. In similarly, like an artificial neural network is made up of artificial neurons. Let us first understand the single neuron. So, yeah, first we have to understand the single neuron, like how it is processed. Let me open another page to understand more. Video page. Yeah, I think this is, yeah, yeah. This is the how neuron implemented as the neural networks using our brain. Just look at the picture and understand. Yeah. Now, it is a similarly an artificial neural network is made up of artificial neurons. So let's first understand the single neuron. It is a single neuron. Sorry. Yeah. This is the neuron. And this is the artificial neural networks implemented by the human brain to understand the artificial. Yeah. Okay. A neuron has a four main parts. First input and second weights and third bias and fourth one activation function. So inputs are the data values. Yeah, these are the bias. Okay, these are the weights. Weights means nothing but the relation of importance between the neurons and the hidden layer. So, and second one is the weights, and third one is the bias. This is bias, and fourth is the activation function. It is the activation function means nothing but the decision maker. Yeah, next. The inputs are the data values and weights represent the importance of each input. I mean weight is the W1 is representing the importance of each input and BS gives the flexibility of the neuron. I mean neuron has the extra flexibility that is considered as the BIANs and activation function decides whether the neuron should be activate or not, which is the decision maker, which is called activation function. I mean, in simple words, the neuron calculates the weighted sum of inputs, add bias, and passes it through an activation function to produce an output. It means in artificial neural network, which is not in the simply of rules and data you give to output, it is as a simple words. A neuron calculates the weight of sum of inputs, add bias, and process through the activation function to produce an output. So, yeah, let me explain the firstly, let me go to the neural network structure. So let me share me another picture. Open. Yeah, this is the one. Yeah, this is the neural network structure. This is the input layer, and this is the hidden layer, and this is the output layer. Okay, so now when we connect many neurons together, we get the neural network. So number of neurons are connected in a single network. It is called as neural networks. So first is the input layer, second is the hidden layer, and third is the output layer. I think we discussed as this is the hidden layer, this is the total single input layer, and this is the output layer. So when come to input layer, the input layer receives raw data. So these are the raw data input layer. So for example, pixels of an image are in neural values. No learning happens in the input layer. It is taken as the purely raw data. There is no trained data or mixed data. It is completely raw data. So in hidden layer, next we are going with hidden layers. The hidden layers is the most important layer, is the where learning happens. This is the most crucial part in the neural networks. Here where we are going to train the data, which is in the hidden layers. So hidden layers extract patterns from the data. For example, in image, first hidden layer detects edges, next layer detects shapes, and the deeper layers detects objects. Like if the layers can be multiple than the normal layers of the hidden layer, so it can be deeper, and it gives the correct answers. So if you have more hidden layers, the output would be the more accurate. So hidden layers are normally nothing like but it extracts the patterns from the data. For example, if an image or first hidden layer detects the edges, and second one detects the shape, and third one gives the object. So it gonna be find out this which comes of which is the picture. For example, if your input you have given the two pictures, one is the cat and one other one is the dog. Hidden can extract the those pixels, which is the dog and which is the cat. Output gives the output layer gives the decision of which is the cat and which is the dog. So when the network has many hidden layers, we call it a deep learning. So here this is the hidden layer, two layers of hidden layer, and it is the one single layer. So if we have hidden layers are more deeper, so which is called as deep learning. So because of hidden layers are very deep. So normally pieces are 28 into 28. So I think equal to 784 or something. So every input are taken as these pixels. So maximum 780, 28 into 28 pixels. So it is considered as a user input, that is the process by the hidden layers of every single pixel through this connection. So every single node connected to the all hidden layers in la- nodes in the hidden layer. So let's go the after that we this is the neural network structure, and we know the how the human brain implemented as the neural networks. Next we have to go to forward propagation. Let's go with forward propagation. Yeah, let me open another pic. This is yeah, this is the forward propagation. Yeah, this is the structure of the forward propagation. Before going in that, also what is forward propagation and why we use in the neural networks? So let me give small explanation. Yeah. Now let us understand the firstly we have to understand the forward propagation. So forward propagation means passing an input data from an input layer to output layer to get a prediction. It means we have to pass the data from input layer and get the output from output layer. So it is nothing but forward propagation means we have to pass the data through the first input and last one is output layer. So here we are going to pass this. The data moves forward through the network. I mean, it has the data moves from through the network, and each layer performs calculations, and finally prediction is the output. Like if the, for example, suppose actual house price is at one, so yeah, like if you taken as the input layer, I'm going to pass actual house price is 50 lakhs. It is the input, and output gives the actual decision is 40 lakhs. So, but actual house price is 50, but the architecture gives the as the neural network gives as the forward propagation is 40 lakhs is which is in the output. But we have faced the 10 lakh difference gap is the this is the loss. 10 lakhs is a loss. So that's why we use loss functions in neural networks because of the reducing the reduce the loss and gives the accurate answer. If you use the loss function in this forward propagation, so we get the output as exact 50 lakhs house is 50 lakhs house. So yeah, it's the actual house is 50 lakhs and 40 is the decision which is the makes in the output layer. But we face the 10 lakhs gap in the loss. So that's why we need means how wrong the prediction is. So that is the using the loss function. So why we have to use the loss function? So we have to use the loss function. So yeah, that is the here same here as the output goes through these and these nodes. Every single node has to attach the output as a 50 lakh. Here the same as we have weights and we have the same. So we have to feed fireball to the output layer. Every pattern this hidden layer connect to the output layer. So this is the forward propagation. So next we are going to also why we have to use the loss function. So loss function is nothing but to tells us how much the error model has the made. So here we are going here loss as the made 10 lakh difference. So we have to reduce the 10 lakhs to normal. We have to use the loss function. So let me give another, yeah, let me give another forward example to you to understand. Yeah, yeah. Yeah, next we are going with the loss functions. So loss functions are nothing these looking like this. Yeah, yeah, this is the loss function. The blue line is representing the train data, and red one is the test data. Yeah, a loss function tells the how much error the model has made. So if the prediction is perfect, I mean, if the prediction is perfect, loss is zero. So if the prediction is wrong, loss is the high. So in there are several types in loss function. There are many several types. So let me make the loss function. So there are large errors are punished the more MSC. So in the one type is MSC. Why it is not working? So first one is mean square error. So that means and it is not working. My keyboard is so yeah, my keyboard is sucking. So let me give the explanation about. First one is the mean square error that is we call as MSC. So mean square error is used to regression problems like it is calculate the square of the difference between the actual or predicted values. It is the predicted by the squares or representing the values. So this is the loss function how it looks. Yo, let me use the another picture to understand the loss function. Yeah, this is the how loss function looks in like in the graph. Yeah, yeah, this is the how looks like the loss function. So let me give us a small. Yeah, loss function has several types, which is the one is the mean square error. We call it a MSE. Mean square error is used to regression problems. Like it is called calculates the square of the difference between the actual and predicted values. Like large errors are punished more in the mean square error. So mainly we use MSE like mean square errors. So it is yeah mean square error. It is a like regression. problems, calculate more errors. Mostly we solve more errors in the mean square errors. So likely in the MSC. So mean square error, which is in the square. So every output is taken as the square 2 power 4. So mean squares are always in the squares. So and another one is binary cross entropy, which means binary cross entropy is used for binary classification problems. For example, spam or not spam. So binary cross classification tells the which is the spam or not taken as an example, and it heavily personalizes the confident wrong predictions. So in a binary cross, entropy is always predicts the always maximum. It is gives the wrong prediction. So another one is the categorical cross entropy. So it is the causal cross entropy is used for multi-class classification. For example, like digits recognition from 0 to 9, like that. So the three mean square errors of back propagations of loss functions. Yeah, this is the graph, how we look representing the loss function in the graph. This is two-dimensional. One is the y-axis and another one is the x-axis. Y-axis is the responsible variable and another one is the explanatory variable. So if we taken as the input as a single line, so how we looks as the slope. Next we are going with, yeah, next we are going with back propagation. Let me share another picture of back propagation. Mm, yeah, this is how back propagation, the background. Yeah, which one is the propagate back propagation? This is the how it is showing the working enough. First we are going to start and next we are going to initialize the parameter initialization. Next it is going forward propagation. Forward propagation means data forward through the first input layer and next thing a hidden layer and last one is the output layer, which is the straightforward like forward propagation. Then after the forward propagation, the input goes to calculate the total errors. So hidden layers can the patterns are check the how many errors or edges are faced this. Next it is going to error back to the propagation to the returns to input layer. Then meet at the stop condition like it is the hidden layer patterns of activation functions. We have the different types of activation functions. So one is like sigmod and relu or softmax. We have to use based on the data. So here the activation functions two works, and then another one is the final output layer, which is that all is as and the output is yes or no, like true or false. So now comes with the most important conceptual concept of back propagation. So let me share another picture of back propagation. Yeah, this is the also similar of, yeah, yeah. Here we're going to start and read the number of layers, which is the hidden layer, and initialize the weights to the small random values like relation, the importance of relations between the, yeah, input nodes to the output node, the hidden layer nodes. So we get that we give the random values. Next, we are going to read the characters and compose the outputs of the successive layers for the training input. So Next, after that, it goes with calculate errors in the output layer. Next, it is going with train it for all layers, which is given the activation functions of training patterns. After, if is true, it is going to start with next is the error of the characters. If it no, it goes with the back propagation like computer weight update. So it goes through the back, then compute weight update of a hidden layers or update weight of all layers. It backs through the to read characters and update the weights, and then it goes to the normal propagation. So why back? So mainly we use why back propagation. So the output is wrong. So here, if the wrong is output, so it goes to back. Normal flow of works it goes back to. So why? But question is which weight caused the error? So yeah, here the output is no, but which weight is caused the so backpropagation finds the responsibility of each neuron and each weight. So that is the role of the backpropagation. So first the loss is the calculated at the output layer. So then the error is propagated backward from output layer to hidden layers. So then each weight is updated based on how much it is contributed to the error. Like so how much, yeah, here. So so here the output goes through backpropagation. After the update the weights and errors, then it goes to the normal propagation. So we have the small chain rule in here. Backpropagation uses the chain rule from calculus. Like it is in simple words, it is calculated how small changes the weight affects the final loss. So this is the how the network learns from the mistakes. So next we go with gradient descent. So let me share on the picture of gradient descent. Yeah, this is the gradient descent looks like. Yeah, a deep dive into a gradient descent algorithm. So his one side is the loss functions. So one other side is the parameters like what we are used. It is aggregated. This is the momentum. So red one is the momentum and blue one is the gradient descent. How to balance the minimum errors to reduce. So let's go with gradient descent. So now we know the how to calculate errors, but how do we reduce the errors? So this is done using the gradient descent. So we know the BRAP propagation. So now we know the how to calculate errors. So we find the errors and using the back propagation. Now how to handle that errors. So that have to we have to use gradient descent. So this is the done using gradient descent. So imagine you are standing on a mountain like blindfold. So you can start to reach the lowest point. Yeah, imagine you are standing on a mountain blindfoldly. So you want to reach the lowest point. Like you take a small steps downwards by fleeing the slope, or this process is called gradient descent. So the step size is called the learning stage. So it is the learning rate is too large. The model overshoots. So it is the too small. Learning becomes slow. So gradient descent means mainly which is taken as a take a small step downward by fleeing slope. So it is the step size is called the learning rate. So it is the learning rate is too large. The model overshoots. If it is small, the learning becomes slow. So this is the how gradient descent works. Next we are going with total output. So we have to choose final model, how it is looks like. This is the final neural network model that includes all the loss functions or hidden layers architecture. Yeah, yeah. This is the whole final total neural networks including forward propagation and back propagation using loss functions and activation functions with an input and hidden layers to find the output. So let us summarize the complete workflow using this. I think, yeah, yeah, this is so. So first one is the input data, which is the given. So this is the input data, and next one is the second is the forward propagation products and product produce the prediction using the hidden layers. Normal data goes through the hidden layers. So these are the hidden layers. And next to the forward propagation, it goes directly to the output. So if weights are wrong, it goes through the backward to find the errors or which weight is the loss or which weight is the error. So yeah, third loss function is calculated the error. So loss function, this is the loss score. So here the loss function works. The fourth one is the back propagation to sense the error backwards. Find the fifth one is the gradient descent, updates the weights. Yeah, this is the gradient descent. This is the optimizer access a gradient descent to update the weights. I mean, which weight is the one to update that weight. So this process repeats again until the model becomes accurate. So so conclude, neural networks learn by adjusting weights, loss function, measures mistakes, back propagation, finds the responsibility, gradient descent improves the model. I mean, so this is the foundation of deep learning. Thank you.